Good afternoon, everyone. Thank you for joining us. My name is Claire. I'm a contract librarian on assignment here with NOAA Central Library. This seminar series is offered through the NOAA Central Library Seminar Program, which provides an educational forum for the presentation of ideas, research updates, and news in support of NOAA's mission. Before we start, I have some technical tips for attendees. Just so you are aware, you are muted and you are not able to unmute. However, if you have a question, you can type it into the question panel, and we will get to those during the Q&A session, which will be at the end of the presentations. Because of the nature of the lightning talks today, please use the name of the person who the question is for when you submit your question. If you're having any audio or visual issues, if you can't hear the speaker or see the slides, please try logging off and logging back on, and that will solve most issues in GoToWebinar. And just as a reminder, this is being recorded. So if you'd like to revisit this seminar or view previous seminars, you can find them on our YouTube channel. Now I'm going to turn it over to Eli, who's going to get the presentation started.
Hi, actually, this is Emily Markowitz. I'll get us started and then Eli will take it away. It's really wonderful to have all of you listeners in. This is the NMFS R users group. And we are just sharing some lightning talks about the cool work that is being done across NMFS in the R and scientific community. On the next slide, I talk about a little bit of what this community aims to achieve. So the overarching vision of the NMFS OpenScapes community is to support scientific researchers within NOAA fisheries by providing training in reproducible scientific workflows and platforms, facilitating collaboration in common scientific data, science tasks, and providing the best practices, resources, and amplifying open science leaders in our agency. If you're interested in joining or learning more, you can reach out to me. That's my email, or Eli, and that's their email, or check out our GitHub organization page. So feel free, it's an open space for people to learn, to share. We also have in our users group Google Space and a calendar and a couple of other resources. So you're welcome to join us. It's really a space for anyone who is interested in this topic, and we're excited to have you there. These lightning talks aim to be a fun and fast way to learn about some of the interesting work that our colleagues are working on across NOAA using R. And in the spirit of sharing imperfect work, we hope to create a more inclusive and supportive scientific community here at NOAA Fisheries and to make connections with our users across NOAA. So cheers to enthusiasm for better science together, and we're really excited that you're here and that we get to share a little bit of the work that we're working on with you.
All right, well, hi everyone. My name's Eli Holmes. I am the other co-organizer of the NOAA Fisheries R user group, and really excited to be here today. We've got 11 speakers from across NOAA Fisheries, including our regional offices and our science centers. This is our second lightning talk session this year. We try to do them every so often to, as Emily said, to share a really wide diversity of work that our users are doing. So I am going to introduce folks as I switch to their slide, and they'll have 3 minutes to give you a really brief introduction to their topic. And then, as Claire said, at the very end, we'll open it up to questions for everyone. All right, so to start things off, we'll have Diana Dishman from the West Coast Regional Office, and she'll be talking about automating biological opinions and permits. Okay, Diana, take it away.
Great. Thank you, Eli. And as folks may have noted, the subtitle of this talk is Why Regional Offices Should Love R Too. So as Eli said, I work with the West Coast Regional Office, and today I'm going to highlight a simple but powerful application of R for those of us who are in policy roles at NOAA Fisheries. So here I'm showing a timeline of a typical consultation process. This example is for Endangered Species Act or ESA Section 7 consultations we do for scientific research permits, although the process is very similar for many types of actions. And in our traditional ESA consultation practice, a biologist would receive information about a proposed action, in this case through an application database, review that information to figure out what's needed for compliance. That biologist would also draft and submit a Federal Register notice, allowing the public to comment. And once a consultation was initiated, analyze the data to determine the extent of potential effects. If needed, the biologist would also work with the applicant to refine the action to avoid or minimize potential impacts to listed species. And then they would draft the biological opinion to record our analytical process, rationale, and final jeopardy determination. And they would also draft any needed permits, memos, or supplemental documents to go with that. So our regulatory timeline for ESA consultation is 135 days. Not only was it a challenge to try to meet these deadlines, given our other workload, but we also recognize that although the specific actions or studies that we're consulting on were different every time, the types of information we received, how we collected it, how we analyzed it, and the tables and documents we needed to produce for the consultation remained consistent. So those features actually all made this process a prime candidate for automation. So Eli, next please. Thank you. So here's the timeline for the same process now that we use automation in R. We still review each unique study coming in and we verify with applicants what they need for ESA compliance. However, we now use our tools to pull data in from the information we receive to generate our tables and documents for us. So if you aren't familiar with R, these hexagons represent packages that each have a different suite of utilities for specific tasks. So our team now has R scripts that use these standard packages to QA and summarize the data for us to review and create Microsoft Word and PDF document drafts in templates that are specific to NOAA fisheries. So we still analyze our QA checks and effect summaries to make our determination and ensure potential harm to listed species is avoided or minimized. And with increased automation, we found that we spend more time and more of the consultation effort reviewing, shaping, and analyzing the proposed action and far less on generating the associated documentation. So the part where we work with applicants is still part of the timeline and our analyst value doesn't change. We just reduce the impact and the workload of the associated documentation. So our biologists are able to focus their limited time on the consultation aspects that have the most impact on our recovery goals. As a benefit, our researchers also get their permits turned around on shorter time frames, typically 90 days or less. Our products are more consistent and we can scale up to analyze many more projects at a time than we ever could before. So if you have a policy process where the way you receive information is standardized, you always analyze input data the same way, or you consistently produce documents in a similar way, your policy work could benefit from using R as well. And that's all I have, Eli.
All right, thank you, Diana. And now we will have Emily Markowitz from the Alaska Fisheries Science Center, who will be talking with us about using R to make survey preparation, communications, and results more efficient. Okay, come on here. There we go.
Hi, yeah. So I'm really excited to share with you guys today about how we're using R in every step of preparing for our surveys out at sea. Everything from before we even go on the survey, for while we're on the survey, and after the survey. And these are tools that are not just for the public, but they're also for us. And so I've got a couple of projects that I wanted to share with you guys today to show you sort of the breadth of things that you can do in R to help make this process easier. The first is we have this website that we use on the boat to help us go through and find materials that we need, and we call it the Race Survey app. And so it used to be that this was written entirely directly in HTML, and not everyone knows HTML, and writing code like that can get quite messy. So we actually moved that into Google Sheets and Distill package. So now that whole website is much easier to change and update and get better information on more efficiently. And that's crucial for us while we're on the boat for knowing how to do a task, resources for forms. We also have an R package called the Gap Survey package. that we use for checking and processing our data and converting files or out at sea. And so it's all contained in there into nice, neat functions that have a lot of documentation and examples associated with them. We even have our project that's used to create our deck posters and binders about special projects and otolith collections. And we just take that directly from the Google form request form that my other colleagues prepare and send out. And so that creates posters on a dime, and we can send that out to get printed at a moment's notice. And the content in there is checked and clean and thoughtfully sorted into those structures. And while we're out at sea, one of the cool things we do is we share bottom temperatures we're collecting in near real time. And this is a big deal because we're on contracted vessels. So it's not something that we would necessarily have immediate access to, but it creates a GIF. We were able to post it online. And so not only can constituents and stakeholders see where we are at a given moment, but also what kind of temperatures we're starting to see as we move through this important area. In terms of results sharing, we are working on a couple of projects, or I'm working on a couple of projects right now to get our data into a more interactive and API-friendly format. Here we're using the Fisheries One-Stop Shop FOSS platform organized by the Office of Science and Technology. And that connects directly from Oracle Apex to them. So all I have to do is create the data and send it through to their platform. And this is going to help us meet PAR requirements that much easier. And of course, the PSS de response, we are running our annual reports and planning committee presentations in R, and they're already 508 compliant. We've had a 3-year backlog that is about to be published imminently, and we're going to be ready and set to run this report in an hour, few hours tops, with a review for the 2022 survey when we get back from sea in September. So R can be used in any step of the process, internally, externally, and there's a lot of ways to bring that into your workflow. Thank you.
All right. Thank you, Emily. And next up, we'll have Amanda Bradford from the Pacific Islands Fishery Science Center, who will be talking with us about design-based line-transect cetacean abundance estimation in R.
Aloha, everyone. My name is Amanda Bradford, and I'm a research ecologist in the Protected Species Division of the Pacific Islands Fisheries Science Center. And I'm here to share a story that is not unlike one many of you have experienced, where you have a complex analysis that you have to conduct a number of times with new data, and you have to remind yourself what you did every time and hope that your old code and hurried notes will help you get the job done. And then you realize they really could use updating, but there never seems to be a good time to stop and invest the effort to upgrade because there is always another survey and another analysis. You know the story. Well, my story is specific to design-based line-transect abundance estimation of cetaceans in the Pacific Islands region, which we've been doing since the first ship-based line-transect survey of the Hawaiian Islands EEZ in 2002 that was conducted by the Southwest Fisheries Science Center back when the Honolulu lab was just a field office. Once we became our own center, we inherited a wealth of line-transect data collection and analysis techniques that had been refined by the Southwest Center over many decades, and that we've been further adapting to our specific needs in the Pacific Islands. I've been with PIFSC for just over 11 years, and we've done a ship-based survey for cetaceans almost every year, which involves collecting sighting data on up to 24 cetacean species for anywhere from 30 to 180 days. We then use an established multiple covariate approach to produce design-based abundance estimates from these data. Our current estimation procedure involves a large amount of custom code that is not well integrated or in a consistent form. Most of the code is in R, although some of it depends on outdated versions of R, but there are also some Fortran routines in the mix. The many data files and coded routines require an experienced analyst familiar with the legacy of our approach, and a non-trivial amount of time is needed for each estimation effort. And ultimately, the code is not in a suitable form to allow rapid replication by in-house or other analysts or stakeholders. And I've wanted to do something about this for a long time, but like I said at the start, it has been so hard to interrupt the cycle, however imperfect, because there was always another species, another survey, or another report to attend to. Also, it wasn't until the proliferation of open data science tools in recent years that I could see a path forward for what an upgrade would look like. To that end, we initiated a project to update the design-based abundance estimation using an open data science approach. This work is being funded by NWFSC's National Protected Species Toolbox Initiative, and we are just about 6 months into our 1.5-year project timeline. I'm leading the project, but the full PI team includes Aaron Olson from PIFSC and Jay Barlow, Karen Forney, and Jeff Moore from the Southwest Center, who have each played a role in developing our current estimation procedure. We are fortunate that most of the contracted programming work is being done by Eric Keene, who does have a background in whale research, but is also an amazing data scientist. And our ultimate goal with this project is to enhance the efficiency, reproducibility, transparency, and collaboration of design-based cetacean line-transect abundance estimation in the Pacific and elsewhere. Our work is being manifested into an R package that we are tentatively calling LT Abund R, although it's possible the name may change, and we are also open to suggestions, so feel free to email me if you have one. The core components of the project are data processing, data evaluation, and parameter estimation, and Eric has made incredible progress in each component. I won't go into all the specifics at this time, but they're on the slide if you're interested. Eric has also created an online book down guide for the package that will continue to be updated, including adding case studies. And since this work is in development, I don't have any links to share yet, but we will share more as soon as possible. And I'm happy to answer any questions you may have during this session or over email. Thanks for your time.
All right, thank you, Amanda. And our next speaker is Alan Olson from the West Coast Regional Office, who will be talking, giving us 2 talks actually. And the first talk will be on a multipopulation proportionate natural influence modeling tool. And the second one will be on a predation competition and delayed mortality risk model. All right, go ahead.
Yeah, thank you. Good afternoon. Like Eli said, my name is Alan Olson, and I'm with the Anatomist Production and Inland Fisheries branch in the Sustained Fisheries Division. And essentially we do, also known as the hatchery branch, and we spend a lot of our time doing Section 7 ESA consultations for hatchery programs in the Columbia River and in Puget Sound. And there's 3, both of these tools that I'm going to talk about are kind of along the same theme. And there's kind of three main or objectives or main points that I'd like to kind of give to folks. And the first off is just to expose you to these 2 of these R-based programs or tools that we use as part of our consultations. The second thing is I want to emphasize, as people build their R tools, is to remember our colleagues and stakeholders that don't code or don't use R, and how do we build tools that non-coders can use. And both of these tools that I'm going to show this morning are examples of that. And then finally, to be a bit of a heretic for an R users group, the other point I'd like to make along the way here is that we shouldn't be exclusive R users. R is a great programming language, but it's not the only programming language, and there's lots of other tools and languages that we can use. And not only that, to remember that, you know, a lot of these tools are evolving. So knowing another programming language other than R is great, and I encourage it. So for this first tool, it's a multipopulation PNI modeling tool, and we use it for looking at genetic influence from hatchery populations on natural origin populations. And both of these tools I'm going to talk about are basically upgrades to existing tools. This one happened to be done in Excel previously, and it was very difficult to use beyond 2 populations. So we've upgraded this to using an R script that that's actually quite short, and it makes it much easier to use to build these models with multiple populations. But the interesting thing, or the thing I wanted to point out here, is that we built this using an Excel interface, basically using Excel as a graphical user interface to get to the R script that's run. And so we've set this up so that anybody in our branch, and most of them are not coders, can use this tool. So, and the nice thing is that Excel already has a bunch of features that make it easy to put together GUIs. It's got command buttons. We can use error checking. But the important thing here is that you have to know VBA, Visual Basic for Applications, to make this work. So again, there's incentive to learn some other languages so that you can meld in with what we can do in R. And I just wanted to point out that we use the OpenXLX package in this. Go ahead to the next slide. Next slide, please, Eli.
I'm trying. Okay, there we go.
There we go. Okay, the other program that, or a tool that we're using is called the Predation, Competition, and Delayed Mortality Risk Model, or the PCD Risk Model. And originally this model was built by Todd Pearson and Craig Busak in Fortran. So when I came on board, what we decided we wanted to update this to a more contemporary package that's more transparent and more user-friendly. So we've basically converted this into an R package. And again, because our users aren't really R coders, for the most part, we've created an Excel front end for this. And the major packages that we've used to implement this is the OpenXLX package, data table, and ggplot. And for example, we've got functions built into this so that we can build 4 standard length frequency plots depending upon what the user desires. And there's a command button built right into the Excel front end so that a user can look at this. Again, you have to know some VBA to run Excel as a front end. And it uses the R script in a command window to make it run. The nice thing about being able to put things into an R package like we have is that you basically make it flexible for both the non-coder user and for folks that are R script writers, that they can basically customize their own PCD risk scenarios. For example, for doing like sensitivity analysis, you can create your own script and run a much more complex scenario using the R package rather than using basically our canned interface. So with that, I think I'm done, and I'll turn it back over to Emmy or to Eli, and I'm welcome any questions.
All right, thank you, Alan. So I am the next speaker. I am Eli Holmes. I'm at the Northwest Fisheries Science Center. And what I want to talk about today is I guess you'd call it kind of production level package. It's a public package. And this is my most developed and public package. This has been out on CRAN for, it's probably coming up on 8 years. It's been a while. I should have checked beforehand, but it's been out for quite a while. And this package will look at, or it's designed to deal with the kind of data that you see in the center of this slide, which is multivariate time series data. So multivariate means there are multiple time series, and time series means it's some data points collected during time. And there is some relationship between these time series. And that relationship could be very, very flexible. So one example would be they are correlated with each other, or perhaps correlated in certain ways. So maybe all these up here are correlated and these two down here are correlated, something like that, and then everything else is independent. You could also have various linear constraints, so that you're saying that maybe this one is a, you know, it's related to these up here in some additive way, like it's the average of them or something. So this model arose because we were dealing with data like this, and we needed to apply models that looked like this over here on the left. This is the mathematical form. These are, it's all written out in matrix form. So you might have X is some function of X at a previous time step, and there's a matrix here. So all the models have this form. It's called a multivariate autoregressive model. And we needed state space in there, which means that you are observing that process with error. It's a very general model that's used throughout engineering, environmental science, statistics, very, very general. And what I did was develop a algorithm. It's called expectation maximization algorithm. And I was able to derive a fully general solution to that opened up the ability to fit pretty much any version of this model. And it's been really interesting, you know, released that. I was using it for fisheries applications, but I put it out there, and it was very, very well documented with a electronic book, and we teach a class on it, and we have lectures and everything. And it's downloaded, like you can see here, you know, over 1,000 times a month. And it's been interesting. It's really heavily used actually in the economics field. And I will not irregularly get emails from people who are at banks and stuff because, you know, this model is used in that setting also. All right, if you want to read more, you can go down to this website. We have a whole website about it. Okay, so with that, I will now switch to Ben Duffin from the Office of Sustainable Fisheries, who will talk about points and polygons and application for Atlantic HMS. Oh, Alan will have to define that.
So, pardon me, so that's kind of a mouthful. It's Atlantic HMS, which is highly migratory species, and then EFH is essential fish habitat. So, highly migratory species, just a little context, is any of the like shark, not any, but most of the sharks and tuna species, swordfish, things like that are highly migratory. And essential fish habitat, just kind of referring to the habitat that those animals are using for, I guess put simply, feeding, breeding, spawning, things like that. So the impetus for this application I was working on, and it's kind of in its first version right now as details get pounded out, but we're coming up on our 5-year review for essential fish habitat for all those Atlantic HMS species. So we were looking for something that could delineate these essential fish habitats, and it kind of had goals of being reproducible. We've got several people across, you know, the whole HMS division that are working on this in different capacities. So we wanted to be consistent in our methods across everybody. I was hoping to make some of those easy to use. Not everybody is an in-depth coder, right? So this kind of gives a graphical user interface to be able to kind of point and click, select different options. And I was looking for a little bit of adaptability. We've got a lot of data that's going to be fed into these kind of spatial models, and it's all formatted differently a little bit. And I'll just take a minute to talk about that center column is kind of the sidebar on the app, and you can see at the top it's, you know, got options to upload CSV or Excel files. And in the app, I couldn't put a whole screenshot, but you kind of get an idea of, it'll give the user a glimpse of what their data looks like. And they'll be able to select whatever spatial data those columns are that represent like the Latin long. And you can kind of see that down towards the center top of the middle column. And then, you've got different modeling parameters you can mess with to kind of see how things will be changed if you choose different grid size. And the middle picture on the right is not actually from the app. It's just kind of demonstrating how, the different parameters can affect your outputs and stuff like that. So kind of moving on down the left side, so the solution was, right, the shiny app. Kind of got ahead of myself there. But pretty much just the workflow is inputting the data, running the data through a kernel density, so you output like a roster surface, and then calculating whatever the user specified % volume contour is from that shape or roster. And finally, having a way to export that where whoever's using it can download the data so that they can use it as a more portable, like I have it set up where it just exports as a shapefile. And so a little bit more about some of the things on the right there. So you can select like, a 50% volume contour, which is that bottom left panel on the kind of composite image there, or larger. And then the bottom picture is actually from the app. So that kind of lets whoever's using it see what the output looks like before they download the file. And they're able to enter, the species name, and it'll generate the file name based on what they put in and the % volume contour. There is some more work that we have planned for this. Like I said, this was kind of the version 1. We have since kind of pounded out a little bit more methods, and I would like to be able to deploy this and share it easily with everybody. And if you have any questions, feel free to reach out.
All right, thank you, Ben. And next up, we have Kelli Johnson from Northwest Fisheries Science Center, who will be talking about alternative text with ggplot2.
Hi, everyone. Thanks for attending today. And I'd also like to thank all of the previous presenters who have talked about first figures in their work. Some of them even referenced ggplot2, which I hope a lot of you are familiar with. And then second, the plug for accessible work. So here on the wall, you can see all these different ggplot2 figures. And what I want to talk about today is building an accessible masterpiece for everyone instead of just you. And everyone here includes those with disabilities, particularly those with visual disabilities. And as we put all of the themes and geomes, you can see each monster here in the beautiful graphic provided by Allison Horst that I slightly augmented with a few new tweaks. The monsters are bringing in all of these features that many, many developers have worked really hard to produce. So we have different themes where you can change the background color, you can make black and white documents, you can make really, really pretty colors and different augmentations, font sizes, those kinds of things. And then the geomes that we're familiar with make different types of figures. You can have a histogram, you can have a line plot, you can have a two-dimensional contour plot. And then we have this third monster with his hand up because currently there's no way to automate the alternative text that needs to be used by a screen reader to make these beautiful masterpieces accessible to those with disabilities. And a few of us are working together on it currently in a package called Braille R to provide automated alternative text for figures that are made with ggplot. So this alternative text is stored in the ggplot object, and then your processes later down the line, such as R Markdown or other tools that you use to visualize these graphics, can pull that alternative text out, place it in the appropriate location, and then when you render, say, to a PDF or an HTML, that automated text is available. So currently, we have different options for alternative text because you can always provide it by yourself too. The first option, which I've crossed out in the list on the left-hand side, is to repeat the caption. This is not preferred by those with visual disabilities because the caption is already being read to them, and so they have to listen to that caption 2 times. The second option is to leave the alternative text blank, and then they have no information about the figure beyond what's provided in the caption. The third option is to teach everyone creating documents how to write alternative text that's actually helpful. This is a really, really big task, and there's lots of rabbit holes, and what is good alternative text is still a bit hard because every individual user interprets it in a different way, the same as your eye interprets things in a different way. And so the option that I have checkmarked is we're currently, we have a grant application in to get funding to provide Apple, sorry, I'm not an Apple person, the iPads, that's the word I was looking for, to people that help write automated alternative text. So we're gonna provide a graphic, and then we hope to use crowdsourcing ways to get to a large number of users and get their ideas on what the alternative text should be. And then we'll have a programmer that helps get that into ggplot2, and then we'll be able to provide it to all users. So I just want to thank you for listening, and in the future, thanks for helping us create automated text within ggplot.
Right, thank you, Kelly. And next up, we'll have Bai Li, who will be from the Office of Science and Technology, who will be talking about automating the backup of GitHub repositories.
Thank you. Thank you, Eli. Hello, everyone. I'm Bai Li. I'm excited to introduce the GH backup to you all. I'm working on this R package with our OST Knaus fellow, Giselle Schmitz. And why do Giselle and I want to create the GH backup package? So according to the NOAA GitHub guidelines on the NOAA Fisheries Integrated Toolbox webpage, you must have a gold standard backup of the repos that are under your NOAA GitHub account. And usually a GitHub organization has many repos. For example, I need to back up repos for NOAA Fisheries Integrated Toolbox, and I'm backing up 6 organizations and roughly 100 repos per month. So it would be nice to have an automatic workflow to download all the repos and upload the backup to a different place for me. To do so, Giselle and I started developing the GH backup package. So if you provide your GitHub token number, and the existing R functions can actually retrieve repo data in your organization from the GitHub REST API, the application programming interface, and it clones all the repos from your organization. And then it compresses and uploads the copies to a Google Drive folder using Google Drive package. We also use the Windows task schedule to do the work at a scheduled time. Right now we are developing another function to make sure the GH backup package also scan all the repos and tell you whether one repo reaches a certain size and needs some special attentions. So Giselle and I just started the work this February, and we really appreciate it if you have any suggestions on how to automate the backup workflow. So please feel free to contact us if you would like to share your experience with us, or just watch us on GitHub. Thank you.
All right, thank you, Bai. And next up, we'll have Nalini Morzaria-Luna from Northwest Fisheries Science Center, and she'll be talking about parallelization and batch processing models with R.
Hi, everyone. I am a marine ecologist at the nonprofit Long Live the Kings, and I am a visiting researcher at the Northwest Fisheries Science Center. Our research group runs end-to-end ecosystem models built in the Atlantis modeling framework. These models simulate marine ecosystems from biogeochemistry, ocean processes, the food web, from bacteria to whales, all the way to fisheries. And we use these models to ask questions regarding fisheries management and human impacts in marine systems. These models are very complex. They have long run times that span hours to multiple days and require a dedicated computer core per run. Often, we need to manage multiple runs to characterize uncertainty, to carry out sensitivity analysis, to run multiple scenarios, and be able to assess trade-offs. So we use R to make sure that these multiple model runs are reproducible, that they're executed transparently and consistently, and that we can scale from a few runs to hundreds of runs easily. We are using several options for parallel processing, where model simulations start simultaneously and run to completion on their own core. Note that because of the Atlantis model architecture, parallel processing doesn't actually make our model run faster. It just lets us do multiple runs. So we run our model locally and in virtual machines in the cloud using Microsoft Azure through support from the AI for Earth program. We use the R package Parallel to simultaneously execute different model runs across multiple computing cores. We are now testing a switch to the R package Future, which results process asynchronously rather than blocking execution until the process is complete. We use R to submit parallel workloads and to manage batch processes across multiple nodes within Azure using Docker containers when we're managing hundreds of runs. We are also participating in a trial for NOAA Cloud, which provides access to a cluster architecture as part of the high performance computing program, but also runs over Microsoft Azure in the background. And this allows us to use R to manage processes across our cluster. Thank you.
All right, thank you. And next up, we'll have Catherine Doring from Northwest Fisheries Science Center, who will be talking about GitHub Actions for R. Use GitHub Actions workflows for R packages with less effort.
Thanks, Eli. So today I'm going to be talking about an R package that I've been developing with Bai Li over about the last 6 months that we're calling GitHub Actions for R. So for those of you who aren't familiar with GitHub Actions can run routine tasks for you in the cloud so that you can do things like run R command check on your R package or update your documentation frequently, and you don't have to worry about your R package getting out of date. So GitHub Actions are really useful, but the challenging part is there's a pretty steep learning curve. So Bai and I were trying to figure out how we could reduce this learning curve. So I just want to highlight some of the features that are available in this GitHub Actions for R package and why you might want to use it with your own R packages that are hosted on GitHub. So the first reason is GitHub Actions for R can provide more functionality with less maintenance. So GitHub Actions for R uses what are called reusable workflows. So maintenance of the GitHub Actions takes place within the GitHub Actions for R package rather than in your own package. And so this also reduces the number of repeated lines of code by storing a workflow in a central location, which is within this GitHub Actions for R package. And already we're using it across a number of repositories. So Eli, if you could just click once. So this plot in the middle shows one of our workflows, and then the dots around it are different repositories that are using that GitHub action workflow. This is actually our doc and style workflow, which automatically runs DevTools document and styler to make sure your documentation and your coding style is always up to date. And so you can see already we have about 10 repositories that are taking advantage of this workflow. And so that's 9 less places that we need the same code over and over. So Eli, if you could click one more time. Thanks. So another reason you might want to use GitHub Actions for R is we tried to provide easy setup. So we have functions like, for example, if you want to use the doc and style R GitHub action that I just highlighted, you could just type in this GitHub Actions for R use doc and style R. Within your R package that you've cloned locally, it'll create all of the files that you need to run the GitHub action. You commit and push those changes up to GitHub, and this GitHub action should be up and running in your repository. So we have things like jobs for R command check, doc and style, and other routine tasks that are common for R packages. And finally, we wanted to be a place to ask for help. We know of the steep learning curve with GitHub Actions for R, so anyone can post questions or issues on our issues page in the GitHub repo. And finally, if you want to learn more, you can go to our package down site, which is located or shown on the bottom right-hand corner. So thank you so much for your attention.
Oops, thank you, Catherine. And our last speaker is Adrian Rios from the Southeast Fisheries Science Center, who will be talking about management history processing.
Thanks, Eli. Hello, everyone. In my lightning talk today, I will be talking about a collaborative effort called the Management History Project. Ultimately, the goal of this project is to provide a comprehensive record of federal fishery management actions to increase the efficiency of fishery stock assessments, ACL monitoring, and ecosystem approaches for fisheries management in the Gulf of Mexico, South Atlantic, and US Caribbean. That analysis-ready dataset goal is represented by the icons on this slide in the upper far right. The activities relating to compiling management events is captured in this slide on the upper far left, and it involves identifying official documentation associated with management actions, and using those documents to generate standardized records for various management events, like the implementation of a seasonal closure, a change in a quota, or minimum size limit. The processing part of the project is in the middle, and it is where we are translating the raw data reflecting management events into a tidy analysis-ready data set. This is the part of the project I would like to highlight with you all today. We are doing this collaboratively on GitHub using R. There are links on this slide, but you can also find the repository by searching for my username, adrianrios-noah. This part of the project is still in progress. And to do this work, we use project boards and track issues on GitHub. We also set goals using milestones. Via GitHub issues, our team has saved a couple hundred emails since January. Instead, those would have been email conversations happen as comments that are linked to their respective task. Additionally, by doing our project management on GitHub, each task clearly indicates its status and who on the team is assigned to it. At the start of this project, all 4 of the main contributors had either very limited or no GitHub experience whatsoever. And now that we use a repository to manage this project, I really can't imagine how we would have kept track of all the ongoing work without it. Without this repository, I also don't think that we would have reached such a collaborative team dynamic where everyone is chipping away at parts of the project and constantly building on the shared up-to-date versions of our processing R scripts. Ultimately, once we have our analysis-ready data set, we plan to create an R data package for it to really make it easy to access and use. Our first related official document supporting an actual stock assessment is linked in the bottom right. It's a nice sample of information that can be generated from this database. The document details a comprehensive timeline of federal size limits, bag limits, and closures for red snapper in the Gulf of Mexico. The larger processing of this comprehensive digital timeline across 13 fishery management plans covers about 70 species. That's all still in progress. However, this first document is definitely something to celebrate. It's the first actual product coming from this really large initiative and effort to establish a comprehensive and reusable source of historical management actions. So it's very exciting to see a part of this large effort finally being relevant and incorporated into stock assessments. If you want to learn more, please check out our GitHub. Thank you.
All right, Thank you to all our 11 speakers today. And we have a little bit of time now for any questions from the audience. And you can see in your little GoToWebinar control panel, there's a little tab for questions, and you can type your questions in there. And I will put up the slide with all the speakers' names so that it'll jog your memory. Here we go.
Great, so we do have a question here, and this question came through while Alan was speaking, but I'm not sure if it's directly addressing Alan or the whole group. The question is, what's wrong with Python? So they provided an example of using Python. So if anyone wants to respond to that, go ahead and unmute.
I can speak to that myself. This is Eli. I also use Python. Python's great. We don't have anything against Python. I've been programming in R for 10, 12 years, and obviously R is more familiar to me, but there's a lot of things I like about Python too. The community is really great and a lot of great packages. I do find, interestingly, that R is a lot better for documentation and the way that we integrate documentation with our websites and having, not websites, with our packages. And what was I going to say? Oh, yes, and having R Markdown. That's like a really nice kind of like ecosphere of things that are built around R Markdown. Anyone else? Any other Python programmers in the group?
I only dabbled in Python, but I think you summarized it really well, Eli. Nothing against Python, I just don't happen to use it, but welcome anyone who uses Python. Yeah, but similar feelings to Eli. I use R, and it has a lot of really nice features that I appreciate.
Hey, this is Ben. I think it'd be interesting to, somebody should study the fisheries research and management side of why R was so highly adopted instead of Python. Because I think it's got a lot to do with like what your peers use. I think a lot of fisheries people end up using R. I've messed around with Python a little bit, but just not enough to be very proficient with it and comfortable doing my day-to-day stuff.
I do think that as we kind of merge with, we interact more, collaborate more with the people who work with Earth data, so satellite data, remote sensing data, which I think, is, we're going in that direction. They use Python a lot. So I anticipate that we'll be learning more Python and using more Python in the years to come. All right, any other questions?
Yes, so the next question here, I'm interested in the R group. How often does it meet, and what are the meetings intended for? Sharing of projects, help with code, etc.
So we have a website, and so you can go there. You can find all our past meetings, which we do a meeting once a month. We also have a calendar that shows not just our monthly meetings, but all kinds of other events happening that are of interest to our users within the agency. We tend to focus a bit on events that are happening within the agency, but we do also sometimes post events that are outside the agency but are of particular interest. We have a very active Google chat group. Actually, it's not Google Chat, it's Google Space, and we'll ask questions and post announcements. I find out all kinds of great things there. It's a very collaborative group. We have about 200 people who are in that Google Space. So just jump on there. If you go to that website, this one that says NMFS R user group, you're going to see at the top, it says, add me to the email list. It's not an email list. You're going to go onto the Google Space. So that's the way to get in. In terms of our monthly meetings, we try to really focus on the kinds of things that you're not going to find in just like a general R presentation, but rather things that are of specific interest to us. You know, we've had sessions on like how to do 508 compliance in R. You know, that may seem dry, but that's a lot of interest to us. We have a lot of the different groups talking about how they're using R, showing their R packages. These will be fisheries applications, really specific to our interest. So we try to hit on anything that people are having a hard time with and they'd like to learn more about, and we do a lot of peer education that way. Like I said, go onto our website and you can see all our past meetings. Did you want to add anything to that, Emily?
Oh, I think you summarized that beautifully. Yeah, it's a friendly place. You know, it's if you think that you're a novice or an expert or you really don't know anything about R, we'd still love to have you. And so it's just a place to learn from each other, be inspired by each other, share our work. I think in this case, sharing and using what other people have done is the greatest form of flattery. And cross-pollination. And so that's, yeah, very much what this group is all about. And yeah, get involved. We'd love to have you.
Great, so it looks like we have time for one more question here. This question is for Emily. Why did you choose Google Drive for data input from the ship as opposed to something like an SQL database or some other database?
That's a great question. I assume that if you go to my slide, you're talking about that GIF of the temperatures as we go through the survey and where we are in the survey. So that data isn't in Oracle yet because we are actively collecting it on the boat. So we're literally on the boat looking at the temperatures that we collected that day and then sending those in so we can make this figure. So that's the primary reason why we're not using SQL and Oracle to collect the data for this figure. But I do use Oracle data to select the stations and other information that we need to make the plot. I also want to give a shout out to AKGF Maps, which is an R package that my colleague Sean Rohan built. And so I use that to do a lot of the mapping work for this function. So I might be leading this project, but I'm leaning on a lot of work done by other people. Is there anything else to add to that? Maybe not. But Google Drive just makes it so that way, so if I can have a bunch of colleagues being on top of this task, not just me while I'm in the middle of the Bering Sea. I can communicate with them. People back on land can do some of the more manual, difficult things to fix that maybe I don't have the internet capacity to do. But we can all see what each other are working on that platform. And it's not just on one person to get something done. If they want to go away for a vacation for a weekend, they can hand it off to someone else to put that data in. So that's basically why we use Google Sheets for this particular project. Make it a team effort.
Excellent. So that is all we have time for today. If you asked a question and we did not get to your question, all of those will be forwarded to the speakers along with your email addresses, so they will be able to follow up with you. And this presentation will be uploaded to YouTube later this afternoon, so you can revisit it if you would like to watch it again. So thank you to all of our speakers today, and thank you to all of our attendees for joining us. After the presentation ends, you will see a survey. If you could take the time to fill this out, we do use those surveys to improve marketing our library seminar service and to inform future seminar topics. Thank you all again for joining us and have a great rest of your day.